Jupiter floats in the darkness like a colossal beacon. From afar, it appears as a banded sphere, a gas giant so massive that it outweighs all the other planets in our solar system combined. What powerful forces create those mesmerizing stripes of orange and white, those endless bands in motion? Today's journey is more than just a visit to a planet. It's an adventure into a dynamic laboratory, where atmospheric physics and planetary evolution converge. This giant, composed mostly of hydrogen and helium, the very elements that make up stars, never quite became a star itself. Instead, it radiates an inner warmth, a silent witness to its stormy origins. What fuels this mysterious internal heat? How do Jupiter's mighty winds carve across its face and keep its eternal dance alive? Today, we'll look closer at its faint halo of rings and its distant moons, lost in the radiant glare of the great giant. What stirs in the depths of this planet? Where have the obvious surface elements gone? What seemingly illogical phenomena are hidden at its mysterious poles, defying human logic? Our journey, guided by stunning original images from NASA's probes and brought to life with meticulous animation, is an invitation to explore these unsolved mysteries. Music. Up close, Jupiter's face splinters into vibrant cloud bands, streaks of ochre, brown belts, and pearly white zones, all running parallel to its equator. These atmospheric stripes are far from static. They are visible signs of powerful jet streams tearing around the planet at unimaginable speeds. Jupiter's atmosphere is arranged in alternating east-west flows, encircling the globe in a dance that intensifies, becoming even more ferocious from the equator up toward the poles. In the lighter zones, clouds of ammonia ice ascend from below, reflecting sunlight into soft whites and pale golds. In the darker belts, we glimpse deeper layers of atmosphere, where clouds, tinged by compounds like ammonium hydrosulfide, cast rusty and amber tones across Jupiter's face. Each neighboring band moves in the opposite direction, an enormous planetary pattern etched by ferocious winds. The speed of these jet streams can reach hundreds of miles per hour, far surpassing any hurricane found on Earth. In Jupiter's upper cloud layers, some winds howl at over 400 miles per hour, and at certain altitudes, even more. The Coriolis effect, working on this rapidly spinning sphere, shatters the atmosphere into dozens of eastward and westward jets, weaving between the bright zones and dark belts, like the signature of an eternal planetary storm. The planet's atmosphere is divided into zonal flows, a vast network of cyclonic and anticyclonic jet streams encircling Jupiter in endless motion. Deep beneath, Jupiter's internal heat, a relic from its ancient birth, powers ceaseless convection, fueling these mighty winds and keeping them alive for eternity. The jet streams carve sharply defined bands that remain astonishingly stable over time. Yet their boundaries are turbulent and wild. We see delicate waves and curls, where fierce winds lash past each other, a testament to the intense wind shear sculpting the cloud tops. Ammonia and water vapor rise, condensing into lofty white cloud bands, while in other regions, descending air sweeps the sky clear, revealing the mysterious, dark layers beneath. The result is a marbled pattern encircling the entire planet, each cloud band a sweeping brushstroke across Jupiter's vast canvas. Amid these stripes, one storm rages unlike any other: the Great Red Spot. The salmon-colored oval cyclone has been raging in Jupiter's southern hemisphere for centuries, vast enough to swallow the entire Earth. More precisely, the Great Red Spot is an anticyclone, a massive high-pressure vortex spinning counterclockwise, the opposite of a typical cyclone, and towering high above the surrounding cloudscape. Up close, The spot's clouds swirl into a dense oval ring, colored like faded brick. A lofty haze at high altitude tints the storm with its signature reddish hue, though the precise chemistry behind it remains mysterious. Perhaps it is colored by complex organic molecules or phosphorus-bearing compounds dredged up from the depths below. Inside, bands and spirals twist and whirl like a gigantic, unblinking eye gazing out into the cosmos. Around the edge of the Great Red Spot, winds roar at speeds reaching up to 268 miles per hour, sculpting the surrounding clouds into mesmerizing shapes that have captivated astronomers for more than 150 years. White ammonia clouds spiral along the storm's perimeter, stretching and being pulled deep into the vortex. From time to time, smaller storms crash into the Great Red Spot, sometimes rebounding off its edge, sometimes being swallowed whole. The Great Red Spot acts as the ruler of Jupiter's atmosphere, its influence stretching far beyond its immediate boundaries, shaping weather patterns across the planet. In recent decades, observers have watched as the spot slowly shrinks and changes shape. It was once twice as large as it is today. Even so, the Great Red Spot endures as the largest storm in the solar system, a symbol of raw power and swirling mystery on this giant world. The Great Red Spot completes a full rotation about once every 6 Earth days, a colossal clock marking the passage of time amid the planet's chaos. At its heart lies a region of relative calm, a stark contrast to the raging jets encircling it. High above the storm, a dome of reddish haze lingers, setting the spot apart from the surrounding bright zones and adding to its aura of mystery. At times, lightning flashes within, momentarily illuminating the swirling clouds from deep inside the storm's ancient core. Far beneath the cloud tops, the Great Red Spot likely plunges down for many miles. Though measurements from the Juno spacecraft suggest it may be relatively shallow compared to Jupiter's immense radius, it still towers well above the surrounding cloud layers. Ultimately, the Great Red Spot is a vast, long-lived, high-pressure system, one of the most enduring and awe-inspiring phenomena in the solar system. The Great Red Spot is something akin to a hurricane's inverse, winds spiraling upward at the top rather than drawing down as on Earth. Its persistence is legendary. Over centuries, it may have changed shape or merged with other major storms from long ago. Yet the Great Red Spot is far from alone. Jupiter's entire atmosphere is a canvas of ever-shifting storms and swirling vortices, painted with constant, mesmerizing turbulence. Music. Along the planet's belts, we find elongated white ovals, smaller anticyclones similar in nature to the Great Red Spot, though much smaller in size. Some of these ovals endure for decades, while others form and fade within just a few weeks. At one latitude, a string of such storms curves around Jupiter's southern hemisphere, like a celestial necklace of pearls draped across the gas giant. If you're mesmerized by Jupiter's eternal symphony of motion and wonder, drop a like, share your thoughts in the comments, spread this journey to your friends, and subscribe to the channel, so you never miss another cosmic adventure with us. These white ovals can merge over time. In the year 2000, 3 smaller ovals combined to form a larger storm known as Oval BA. Oval BA, nicknamed Red Spot Jr., later turned red and grew to about half the size of the Great Red Spot. Between these major spots, Jupiter's clouds teem with turbulent currents. At the boundaries of the swift jet streams, wind shear gives rise to twisting, filament-like patterns, delicate swirling strands that wrap around the planet. We see swirls where dark belts meet lighter zones, most likely Kelvin. Helmholtz. Waves. Formed when 2 layers of air slide past one another, creating elegant, wave-like clouds. Within the belts, dark barges drift by, while bright, popcorn-like clouds pop up, powerful thunderstorms, erupting upward in convective bursts. Jupiter's atmosphere has no solid surface to interrupt these winds. Here, the air flows freely, unbroken, creating an endless dance of clouds and storms. Storms on Jupiter can plunge deep and last far longer than any earthly tempest. Tracing the curve of the planet, we see countless rotating structures, from compact vortices only a few hundred miles wide to sprawling, chaotic regions where multiple storms interact and collide. These turbulent mergers and collisions routinely disrupt the regular patterns of the cloud bands. For example, a turbulent region often trails behind the Great Red Spot, where the storm's flow disturbs the adjacent belt, spawning clusters of vortices and pale clouds. This zone of turbulence acts as a storm nursery. Here, new vortices are born amidst the chaotic shears. Yet, amid all this apparent chaos, there is a certain order, a hidden rhythm to the planet's endless turbulence, a mysterious heartbeat pulsing through Jupiter's atmosphere. Each storm on Jupiter tends to stay within its latitude band, locked in place by powerful zonal jet streams, like wild spirits caged by atmospheric boundaries. For all the striped chaos of Jupiter's equatorial and mid-latitude regions, a surprising order reveals itself at the poles. Soaring above the poles, the Juno spacecraft uncovered a breathtaking secret: polar cyclones, arranged with stunning geometric symmetry. At Jupiter's North Pole, 8 massive cyclones encircle a central one, forming a nearly perfect octagon of storms, swirling in harmony. Each of these polar cyclones is gigantic, about 1,500 to 2,800 miles across, yet they nestle right next to one another without merging. All spin counterclockwise, their spiral arms nearly brushing but never colliding, held apart as if by an invisible force that keeps them from crowding too closely. Music. The pattern is truly mesmerizing. A living polygon of synchronized cyclones, bizarre yet beautifully stable. As if Jupiter itself is showing off its cosmic geometry to the universe. Jupiter's South Pole displays a similar spectacle. Originally 5 cyclones circling a central one, later joined by a 6th to form a stunning hexagon of storms. These polar clusters have remained remarkably stable through years of observation, barely shifting from their places. The symmetry hints at hidden physics, perhaps a delicate balance of vortex flows and jet stream boundaries, locking the storms in their celestial dance. Suddenly, a brilliant flash lights up the planet's clouds. Lightning strikes on Jupiter. For a heartbeat, the cloud tops are illuminated with an intense glow before darkness returns. Jupiter's thunderstorms unleash lightning bolts that rival and sometimes surpass those on Earth. Ever since Voyager first caught fleeting glimpses of lightning at the cloud tops in 1979, we've known that lightning on Jupiter is born deep within the water cloud layers, where temperatures and conditions mirror those of Earth's fiercest storms. But NASA's Juno mission uncovered a remarkable new twist. Jupiter also has shallow lightning, electrical discharges flashing high up in the atmosphere within clouds made not just of water, but of a strange ammonia-water mixture. In these frigid upper layers, where temperatures plunge to about -126 degrees Fahrenheit, normal liquid water can still exist, but Jupiter's abundant ammonia acts as a natural antifreeze. During powerful storms, icy hailstones are hurled upward, rising some 15 miles above the usual cloud decks into regions rich with gaseous ammonia. The ammonia melts the ice, forming droplets of slushy ammonia water, an otherworldly mush unknown on Earth. Inside these alien thunderclouds, rising ice crystals collide with falling hailstones saturated with ammonia, nicknamed mushballs. And these collisions generate static electricity, creating flashes of lightning in Jupiter's upper sky. result, lightning crackling through Jupiter's upper atmosphere, far higher than scientists once thought possible. These shallow lightning bolts slash through ammonia-laden clouds, momentarily illuminating towering storm structures in eerie blue and gold light. Juno has detected these flashes on the planet's night side, each lasting only milliseconds yet shining nearly as bright as the lightning we know on Earth. Deeper down, in the more familiar thunderstorm regions, 30 to 40 miles below the cloud tops, lightning is just as intense. Here, water exists in all three phases: ice, liquid, and vapor, just as in Earth's towering cumulonimbus clouds, fueling powerful charge separation. Some of these bolts are colossal, unleashing energy several orders of magnitude greater than a typical lightning strike on our own planet. Juno detected thousands of lightning flashes, even hearing their crackling radio signals, the so-called whistlers, as it soared above Jupiter's cloud tops. Fascinatingly, it was Juno's discovery of shallow lightning that solved the long-standing mystery of Jupiter's missing ammonia. Mushball hailstones were carrying ammonia deep into the atmosphere, depleting it from the upper layers and hiding it from view. Once again, we witness a brilliant flash slicing through a distant cloud bank. Lightning briefly illuminates massive convective cloud towers that rise above the surrounding haze. These titanic towers can soar up to 30 miles high, driven by Jupiter's internal heat. In that fleeting glow, we glimpse the outline of a colossal thunderhead, perhaps the very birthplace of ammonia-rich hail tumbling earthward after the strike. Now, let's rise above the clouds and storms. High over Jupiter's poles, shimmering auroras of staggering power dance across the sky. Each pole is crowned by a constant halo of glowing auroral radiation, an ethereal blue-violet light that pierces the planet's darkness with otherworldly brilliance. Jupiter's auroras are the most intense in the solar system, hundreds of times more energetic than Earth's northern lights. Unlike the fleeting auroras that flicker on Earth only during solar storms, here, the auroras never cease. They're powered not only by the solar wind, but also by the planet's immense magnetic might. Jupiter's magnetic field is estimated to be 16 to 54 times stronger than Earth's, generated by metallic hydrogen swirling deep within the giant planet's core. If you're mesmerized by Jupiter's eternal symphony of motion and wonder, drop a like, share your thoughts in the comments, spread this journey to your friends, and subscribe to the channel, so you never miss another cosmic adventure with us. This magnetic field captures charged particles and funnels them toward the poles. When these high-energy particles smash into Jupiter's upper atmosphere, they excite hydrogen molecules, causing them to fluoresce in ultraviolet and infrared light. The result is immense oval rings of auroral light encircling each pole, a cosmic halo visible across space. In the images, Jupiter's northern aurora blazes with an electric blue glow, spiraling under the sway of magnetic forces. These auroras are powered in part by the planet's rapid rotation and by its moons. Volcanoes on Io, Jupiter's innermost major moon, erupt and hurl tons of ionized sulfur and oxygen into space, which become trapped in Jupiter's mighty magnetic field. As Jupiter spins in less than 10 hours, it drags its vast magnetosphere along, flinging ions toward the poles and fueling the planet's never-ending auroral storms. That contribution is so great that it creates footprints in Jupiter's auroras, bright spots corresponding to magnetic connection points between Io and the planet's upper atmosphere. Similar auroral footprints are created by Europa and Ganymede, with one standing out as an especially bright, pulsating auroral spot at the edge of the northern oval. Additionally, bursts of solar wind can amplify the auroral glow, causing the lights to flare even brighter and more spectacularly. Observations from the Hubble Space Telescope have revealed auroral curtains rising thousands of miles above Jupiter's cloud tops, surpassing anything ever witnessed on Earth. Yet, even an observer standing within Jupiter's atmosphere would be unable to see these colossal glowing rings overhead. That's because Jupiter's auroras glow at wavelengths our eyes cannot see, primarily ultraviolet. On top of that, they emit high-energy X-rays as well. In fact, Jupiter's auroras shimmer with intense X-ray bursts, a phenomenon that scientists are still unraveling, working to understand how these particles are accelerated to such energies. Now, let's pull back even farther from the planet's surface. Set against the black canvas of space, Jupiter is encircled by something unexpected, a faint set of rings surrounding the giant. They shimmer like strands of spider silk, delicate and elusive. Jupiter's rings are nothing like the bright, sweeping arcs of Saturn. These are thin, almost transparent bands of dust, so tenuous they went unnoticed until their discovery in 1979. In this image, we see Jupiter's main ring as a slender, bright line hugging the planet's equator. A subtle halo lies within, and a wide, diffuse gossamer ring extends outward. These rings twinkle in sunlight, appearing as a faint white line cutting across Jupiter's night side. They are 1,000,000 times fainter than the planet itself, made of tiny dust grains rather than dazzling chunks of ice. So, what maintains such delicate structures around this colossal planet? The answer lies right in orbit: Jupiter's small, inner moons. Two of these moons, Amla and Adrastea, show up as faint points of light within or near the rings. In this image, Amthea appears at the left edge of the ring system, a tiny white dot with a barely noticeable diffraction spike, confirming its presence in the JWST's infrared view. The even smaller Adia appears as a mere speck of light at the very edge of Jupiter's main ring. These delicate rings persist because the moons are constantly replenishing them. Unlike Saturn's icy rings, which may be the remains of a shattered moon, Jupiter's rings are formed from dust created by relentless micrometeoroid impacts. When space debris strikes the surfaces of tiny moons like Adrea or Metis, it blasts particles into space. These particles drift into orbit, gradually forming rings around the planet. Over time, countless impacts build up a ring of dust. Adrea, only about 12 miles across, orbits right at the edge of the main ring and serves as its primary material source. The slightly larger Metis, though not pictured here, contributes as well. Farther out, moons like Amma, about 155 miles wide, and Phoebe shed dust that forms the faint gossamer braids of the planet's outer rings. Data from the Galileo spacecraft confirm this mechanism. Jupiter's rings, truly, are composed of dust blown off its tiny moons. The vertical thickness of the main ring is just a few miles. Up close, the particles are microscopic bits of silicate rock, likely dark in color, which explains why they reflect so little sunlight. They're virtually invisible to the naked eye unless seen in infrared or under backlighting, just as we are seeing now. And there it is. Jupiter, a dynamic system in its own right. Atmosphere, magnetosphere, rings, and moons, all bound together in a complex gravitational and electromagnetic dance. We observe atmospheric bands stretching across its latitudes, containing storms and channeling energy from the planet's depths to its skies. We can feel Jupiter's internal heat still radiating from a primordial furnace, fueling the convection that gives birth to thunderstorms and towering clouds. Invisible lines of magnetic force stretch from its depths, linking to the glowing auroras at the poles, weaving through Io, driving electric currents that ignite the planet's polar skies. Jupiter's rapid rotation weaves all these forces together, sculpting the bands, aligning the cyclones, shifting the magnetic field, and even helping keep the rings pressed into a flattened, shimmering disk. From this perspective, the planet is a true symphony of motion and energy. Fluid dynamics, electricity, magnetism, gravity, all playing their parts on a grand cosmic stage. Now, all these elements converge in a single portrait. Jupiter is a world of perpetual transformation and overwhelming power. There's no need for a conclusion. For whatever words we choose, Jupiter remains what it has always been. A majestic, mysterious, and forever dynamic gas giant, holding within itself the echoes of creation and the ever-unfolding drama of the cosmos. If you're mesmerized by Jupiter's eternal symphony of motion and wonder, drop a like, share your thoughts in the comments, spread this journey to your friends, and subscribe to the channel so you never miss another cosmic adventure with us.